Space, an everlasting universe of galaxies and stars. But there is one danger that comes out of these awing galaxies: meteors.
Did you know over 10,000 pounds of space dust hit Earth every single day, but almost all of it is in microscopic form? The real question is, how big does a meteor have to be to hit the Earth? I'm trying to solve this to help scientists all over the world have a better knowledge of whether or not a meteor could have a possibility of hitting the Earth.
Meteors have been hitting our big blue planet for over millions of years, and meteorites have been found all over the world, from the deserts of Arizona to the tropics of Mexico.
The bigger the meteor is, the more chance it has to hit the ground. Common sense, right? Well, wrong. The meteor the size of a golf ball and the meteor the size of a house will both most likely hit the ground, but different sizes. They will both get grinded up and burned until friction will no longer affect their travel.
My two variables for this experiment are size in tons and whether or not it hit the Earth. Here is a small list of some meteors that hit the Earth and their size. Unfortunately, there were no materials or procedure provided for this experiment. Conclusion: how big does a meteor have to be to hit the Earth? When meteors have a collision course for Earth, it is only common sense to know that the bigger it is, the more likely chance it will have to hit the Earth. Based on this reason, the bigger the meteor is, the more chance it will have to hit the Earth. During research, it seemed as if all meteors that enter Earth's atmosphere made it into the ground, because once it gets small enough, friction would no longer cease to disintegrate it. When meteoroids get small enough, about dust particle size, they will move about 1 inch per second through the atmosphere. Multiple meteorites have been found on the ground, all of them very small. The stated hypothesis was false. It is stated that almost, if not all, meteors that enter Earth's atmosphere make it to the ground. The results were not expected, as it would seem only meteors so huge could make it to the ground. This experiment will help scientists determine whether a large meteor be threatening to Earth or as small as a speck of dust. But since only meteors of the same material were from data, it would be reasonable to have also more experiments on other types of meteoroids. Error analysis. There are many errors in this experiment. One of them are that the tester had no control on getting the meteors to enter at a certain time or at a certain weight. There is no chance to have multiple meteoroids of the same percentage of stone and iron. Also, there is not an exact weight of how big the meteorites are, as tourist oily hands will fade away the meteorite. Future applications and future research. This experiment will hopefully benefit scientists who need more knowledge on meteors that will hit the Earth. The experiment contributed to the astronomy community as a helpful tool to look to if a meteoroid will be big enough to cause damage. Now that research has proven that almost all meteors will hit the ground, scientists should now research and test how big a meteor will be when it hits the ground if it enters Earth's atmosphere at a certain weight.